afternoon all. Now in this video, let us see what happens when AC flows through LR CR LCR circuits, right? It flows through LR CR LCR circuits. So first let us take LR circuit. Here I am connecting resistor and inductor in series to our AC generator, whose EMF is equal to E0 sin omega t. Right? Now here we will get the maximum current as I0 equal to E0 by under root R square plus omega square L square. So this is the maximum current flowing through LR circuit, right? Now we know current value as I0 sin omega t minus pi. Here when current flows through the inductor, what is happening? Current lags behind the voltage, we are saying. That is, here a phase difference is occurring between current and voltage. So only sin omega t minus minus pi. So I becomes E0 by under root R square plus omega square L square sin omega t minus pi. So this is the current flowing through LR circuit, right? Now similarly, even we can find out the value of this phase difference. Okay, so that is tan pi, right? That will be equal to omega L by R, where omega L is the inductive reactance, the opposition created to the current AC by inductor. R is the resistance of resistor, or pi equal to tan inverse omega L by R, right? Similarly, we can also find here the impedance due to LR circuit. So Z is written as E0 by I0. So E0 by, what is the I0 value? E0 by under root R square plus omega square L square. E0 strikes off. So Z becomes under root R square plus omega square L square. This is the impedance generated or produced due to LR circuit when AC flows in a LR circuit, when AC flows through LR circuit, right? Now let us draw the vector diagram. Okay, right? So now here resistance, the voltage drop along the resistance IR, voltage drop or potential drop along the terminals of inductor IXL, that is I omega L, right? Let us represent our ER along x-axis ER. Okay, we know that when AC flows through the resistor, current and voltage are in phase. They will be in same direction. So I wrote current also along this x-axis, right? Now here in inductor, already in our last video we find out that in inductor current lags behind the voltage. Means voltage leads the current, no? Current is lagging behind means voltage is leading. So that leading voltage in inductor, I am indicating along positive y direction, that is EL. So the resultant, this gives the resultant EL. So resultant will be equal to under root EL square plus ER square, right? So this is the vector diagram. Now similarly, let us see what happens when AC flows through CR circuit. Okay, first capacitor and resistor are connected in series and then connected to the EMF source or AC source. E equal to E naught sine omega t, right? And as phase difference is occurring for the current and voltage when AC flows through the capacitor, the current is written as I naught sine omega t minus pi. So maximum current comes out to be E naught by under root R square plus 1 by omega square C square, right? So now here we can write current as E naught by under root R square plus 1 by omega square C square sine omega t minus pi, right? Now next, the impedance E naught by I naught. Okay, E naught strikes off and okay, I will write E naught by under root R square plus 1 by omega square C square, that is equal to under root R square plus 1 by omega square C square. Now what is 1 by omega square C? Nothing but capacitive reactance, the opposition created to the AC current by capacitor, we call it as capacitive reactance. Okay, similarly we can also find the phase angle pi equal to tan inverse 1 by omega CR we will write. Okay, now even we can draw the vector diagram. How we will draw the vector diagram? As usual, I am taking the resistance ER along x-axis and our current also flows along this same direction in resistor, and here in case of capacitor, current leads the voltage, means voltage lags behind the current, no? So voltage is lagging behind the current. So this is EC. Now the resultant one is in such a way, which is nothing but E, okay, that is equal to under root ER square plus EC square, right? Similarly, let us see what happens, the value of impedance when current AC flows through LCR circuit, when AC flows through LCR circuit, right? So now here in LCR circuit I am connecting resistor, capacitor, inductor in series to AC generator. Okay, right? E equal to E naught sine omega t, right? So I naught value comes out to be E naught by under root R square plus omega L minus 1 by omega C whole square. R resistance due to resistor, inductive reactance, and this is capacitive reactance. Similarly, we can write pi also as tan inverse omega L minus 1 by omega C by R. Similarly, we will get impedance as E naught by I naught. So, substituting the I naught value, we will get impedance as under root R square plus omega L minus 1 by omega C whole square. Right? Now, next, let us draw the vector diagram. As usual, along x-axis, I will take ER. Right? Now, here EL leads ER. EC lags behind ER. So, the resultant of EL and EC becomes some OB, that is EL minus EC, and the resultant one is this. Okay, with a phase angle between them. R is the resultant. OR indicates the resultant of all these currents. Okay, so now this is about what happens when AC pass through the LR CR LCR circuits. We calculated the impedance values for this and we just saw the relationship between ER, EL and EC. Thank you.